Snow has been found in the waters of Wanaka.
We picked it up in 2008 when one of my PhD students, Tina Beyer, started her PhD working on Lake Wanaka. We picked it up the first time we went sampling. We just dragged a zooplankton net through the water and looked in it and thought, wow, what's this stuff? This stuff that looks like snowflakes.
Marc came up with the idea that it must be something like what other people find in the ocean, which is called marine snow over there. So we called it lake snow, and then we looked into the literature and we saw that it was actually a thing to occur in several lakes, but it doesn't seem to happen very often. And Wanaka is actually the only lake up here where we found it.
So just how did this snow get in the water?
Lake snow is formed in a number of different ways. From the literature, it seems that it can be formed by algal blooms where algae dominate, and the algae produce a lot of this polysaccharide. So they basically secrete it on the outside of the algal cell, and for some reason they secrete a lot of it and secrete it in excess. And so then they can end up sticking together and forming snow. And in Lake Wanaka that we're studying at the moment, where we've picked up this lake snow a couple of years ago, the dominant alga is a diatom. Cyclotella it's called. Actually, I can just show you right here, since I'm wearing my Cyclotella hat. These are actually Cyclotella. And it's exactly this genus of diatom in Lake Wanaka that appears to be producing a lot of the polysaccharide, which ends up forming the lake snow. It's the glue that holds the lake snow together.
So how has the lake's newest resident come to be?
We know that land use and development have intensified in the Lake Wanaka area, so there's probably more nutrients coming into the lake, plant nutrients like nitrogen and phosphorus, which farmers put on their fields to stimulate plant growth. Well, when this runs off into lakes, it stimulates algal growth in the same way.
But with proliferation comes problems.
Fishermen have reported a fouling of their fishing lines, which started in 2003. It was very clear when that began, because prior to that no one had ever had any trouble with fishing lines getting fouled by this algae. Since we've been studying it, we've been in touch with fishermen who've been supplying us with samples and telling us, when it first came in and where they're finding it and all that. The township of Wanaka takes its water from the lake, drinking water, and in the last couple of years they've been having some problems with the filters at their water intakes clogging up. And they've also been having problems with clogging inside the reticulation system, and actually at people's showers and people's washing machines. There's been a whole lot of cases of people having their water pipes clogged.
However, people are not the only ones who use the water.
Lake Wanaka, along with many other of our, what I call the southern Great Lakes, the lakes that drain off the southern Alps, are incredibly nutrient-poor systems because they drain mostly untouched areas, and their water is mostly glacial meltwater or snowpack water or just rainwater. They have very low nutrient levels, and that's why these lakes are so clear and blue in color. And that's why we love them so much, and we think they're just so iconic and beautiful. One interesting thing about lake snow is by concentrating a lot of biological activity into these flocks and particles, I see them as potentially a kind of oasis in this big desert, nutrient desert, which is the lake. So from an ecological point of view, the lake snow could be a really important concentrating mechanism for biological activity. It affects people, it affects fishermen, and it affects people who take their drinking water from Lake Wanaka. But it's also a really interesting and rare thing in lakes, and it could affect the things that live in lakes, like Lake Wanaka.